Hello everyone, today we're going to talk about mid-latitude cyclones and lightning. Okay, so mid-latitude cyclones is a storm system, right? So it's a low pressure center that's rotating counterclockwise because again the air is rising at the low pressure center, right? And as the air flows in towards the low pressure, it curves to the right because of the Coriolis effect. And what that does is it causes this rotation of air over the mid-latitudes, so the main part of the United States of America. Okay? And as that travels across the U.S., it's going to influence our weather. So, for example, here you can see the maritime tropical air from the Gulf of Mexico is getting pulled up to where we are near Chicago here by this mid-latitude cyclone. And that's going to result in a variety of weather patterns. Okay? One of them is that the mid-latitude cyclone has a classic kind of typical comma shape to it. Okay, if you have a very well-developed one, you can see it on that satellite image here. And here's the animation showing that occurring. At the end here, you can see the dark to the right here. That's just nighttime. This was a satellite imagery that was taken. And you can see here on the right side, so right at this leading edge there, that's your cold front. So you got the rotation. You can see the low pressure is going to be right here, rotating counterclockwise. You see it spinning, and it's going to be pulling that continental polar air. Okay, so cooler, drier air down from the north here. And then on the right side of this cold front, this is your maritime tropical air. So this would be hot, warmer temperatures, high humidity. And then as a result, you can see where that cold front hits that warm air. So the warm front would be up to the north here somewhere. So this is just a big body of warm, humid air. Where that cold air hits, you see the storm development. And even at nighttime, you can see kind of the thunderstorms in the shadows there. Right at the end of that image or animation. So we're going to expect different conditions. So at that leading edge where that warm front is, just like all warm fronts, we're going to expect kind of cloudy, rainy conditions, and then you get some just warm, sunny conditions kind of in between the two fronts. And then where that cold air is hitting, we're going to anticipate to have a severe weather. Okay, on that leading edge right in front of that cold front, where we're going to find a bad storm. Okay, so this is just a picture that kind of shows that development of the storm. So we'll just let that play here for a second. All right, so that system just, is just that animation is showing how that system develops, okay? And it starts with that Coriolis effect, right? And then it's just pulling those different air masses, right, in different ways. Now, here's the key when we're looking at all of these things is, if you have up in the north here over Minnesota, let's just say that this is a poorly developed or maybe a well-developed mid-latitude cyclone. We've got this low-pressure center up to the north here, right? All of these systems are going to move from the west across to the east. So what does that mean? Wherever we are, right, that's the weather of today, okay, obviously. So here in Chicago, Wheaton area, this is what the weather would be. The weather off to the east of us is what the weather was a few days ago, okay? So whatever was here is going to move off to our east, right? And then we can then look kind of conversely off to the west. Whatever weather's happening to the west is going to be what's coming to us, okay? So today, for example, if we were looking at this location, it'd be warmer temperatures, right? Because we've got this warm air coming up out of the Gulf, okay? That's what we would anticipate to be occurring. And then we would anticipate in the next few days, this cold front is going to be coming down, right? So this low pressure center is going to move its way across the U.S. and we're going to get that cooler temperatures. And then potentially some storms, right? Depending on how much moisture or humidity was in the air. Along that location. All right, let's move on and talk about lightning, why it happens, or what it's all about. So I thought this was a really cool picture here, and it's showing 10 hours of lightning down over Florida. And you can see, I put in there that 90% of the lightning in this area occurred from May through October. Okay, and think about why that is. And it has to do with, of course, the warm temperatures, right? So during the daytime down there, during the summertime, you get warm temperatures, so you get a lot of storm development occurring. Okay? Now, how lightning happens, or what's happening here, is you basically have, in a thunderstorm, right, you've got these ice crystals and these water droplets that are flying all over the place, especially in a strong, powerful storm. And in that system, you tend to get, the raindrops tend to get a negative charge, and they tend to sink to the bottom part of the cloud. So the cloud, a big thunderstorm that, is 30,000 feet tall, will have kind of a positive charge up at the top part of the cloud and then a negative charge along the bottom. And what that does then, that generates an electric field with the surface of the Earth. Okay, and if that field becomes great enough, you can get this electric discharge between them. So normally air is an insulator, right? It can't transmit electricity, thank goodness. But if you have this big difference between the negative field along the bottom part of the thundercloud and then the positive on the surface of the Earth, you can get a lightning strike. So you can see what's happening here. This is just a step leader. So it's basically the negative charge kind of follows ions and trickles its way down through the air. And then the same thing occurs down here at the bottom with a positive charge, and those are called streamers. And when they come into contact, you get the lightning strike. And you can see the picture to the right here. This is an actual photograph showing, and you can see the positive streamer reaching up, and it was using the tree, right, to go through here. So most lightning is going to happen within a cloud, right? But sometimes, and depending on the factors of the storm system, right, you're going to occasionally get some cloud to ground as well. Okay? So this is just a picture showing what I just explained, where you get that difference in charge between the top of the cloud and the bottom of the cloud, and that's ultimately what will drive that electrical discharge. Okay? So it's that positive buildup on the surface and the negative buildup on the bottom of the cloud. Okay? So this is just kind of a crazy picture showing that. Some myths and facts. Let's look through these. First, rubber tires, foam pad, or rubber-soled shoes will insulate me from lightning. Okay, so this is something some people think. If you wear some rubber boots, you're going to be safe from everything. That is false. It takes about 10,000 volts to create a 1-inch spark, and lightning's got millions of volts, right? So it's going to have no problem jumping a great distance. So that's not going to help you out at all. All right, lightning never strikes the same place twice. Okay, good saying maybe, or often used saying, but that is also false as well. So there's nothing to prevent lightning from striking a location multiple times. Some people, unfortunate souls, have been struck by lightning multiple times in their life. This animation, this video is showing, I think the Hancock Tower, Trump Tower, and Willis Tower being struck by lightning. They get struck obviously multiple times during the year, and we want them to be struck because we can, use electric or lightning rods to be able to direct that electricity where we want it to go. Okay? What about when you're out boating? Right? If you're out on the water when you're boating or canoeing or sailing, what should you do? Should you get off the water? I would, but a lot of this one kind of depends on the circumstances, right? So depending on where you're at, and maybe if you're getting off the water, it's getting into a worse scenario. So kind of a tough call, but generally speaking, that's why it's good to get off water well before the storm arrives, right? That way it's not going to be a concern for you. So kind of a sad story, but also good for you guys, I guess, to see, is that this girl was struck and killed by lightning shortly after this picture was taken. So you can see her hair standing up, and this is what happens because this is that positive streamers or leaders and streamers from the surface of the Earth traveling up. That's that positive charge, and it's using her as a conduit, right, to then get into contact with that negative portion of the storm cloud up above. So, again, when lightning is in the area, take it seriously. People are killed every year. So this is showing a golf course, of course. You can see how the lightning travels along the ground, which is why it's not safe to stand underneath a tree, right? So these cattle were trying to hide underneath a tree, and they were all killed by the lightning that struck the tree and then traveled through the ground and electrocuted them. So these activities, look, this is where people are killed, lightning casualties, basically over the past 50 years. So fields, trees, water, those three places, bad. Okay, so stay away from those. And then here, look in the past decade. These are the lightning fatalities that have occurred from 2010 up to 2020. The big thing I want you to take away from here is, look, this is the breakdown by gender between male and females. And notice that a lot more guys are killed. And there's probably a variety of sociological, psychological reasons for this. I can just think, just generally speaking, might have to do with jobs, right, that people are doing. Also, maybe to do with maybe men are less likely to take it seriously. That's possible as well. Okay. All right, some interesting lightning facts for you. So most victims are children and young men engaged in recreational work. So 25% of the victims die. Others suffer long-term effects. And again, most of them are male. So guys, be smart, okay, and you ladies as well. But statistically, guys end up kind of not paying attention to this kind of stuff and get killed more. So most strikes occur in the afternoons because that's when those storms are occurring. So where are you safe? Inside a walled and enclosed structure. So it has to have a roof, has to have walls. You're not safe anywhere that's exposed. So if your garage door is open, you're not safe. Okay? If you're in a baseball dugout, you are not safe. If you're in a picnic shelter, you are not safe. Okay, so just be real smart with everything. And there you go. All right. Hope you guys have a great day. Let me know if you have any questions.